All right, so we've already practiced all of these with drawing the final Lewis structure. But now I just want to go through and say, how many resonance structures does these molecules have? So we ended up with this guy for our HNO3. Remember, we could have moved and made a double bond with the O with the H's or on one of the other ones. So now I want to ask you, well, how many resonance structures do I have? So does this one count? Here, it was all single bonds, but nitrogen isn't full. He's only got 6, okay? So that one doesn't count. To make him happy, I could have moved it here or here, okay? So to make him happy, I had the choice of here or here. And so that means that I have 2 resonance structures, okay? Moving here doesn't count because it's not stable, it's not a real structure, okay? So it has to be a legit structure. So I could have put the double bond here or here, so that's 2 resonance structures and they're equivalent. So if I asked you how many resonance structures does HNO3 have, your answer would be 2. All right, let's do the next one. So CO2. So CO2, if it were all single bonds, it wouldn't have been enough. If it was here, he only has 6 electrons, so I had to move. And my only choice was this. So if I ask you how many resonance structures does CO2 have, your answer is only 1. Because I didn't really have a choice. I had to pick this guy to move. He's happy. He was done. There's only one picture. I don't have a choice. Where here, I had a choice because these 2 are equivalent. So when I ask you how many resonance structures, your answer really could be 1. So this is 1. All right, let's look at SeOF2. Let's look at if it was all single. If it was all single, this Se had 8. So this is a counted structure, okay? Then the only choice was to make a double bond here. So my choice was no double bond or 1 double bond. So if I ask you how many resonance structures, your answer would be 2. Are these 2 equivalent? No, okay? Because this one is less stable than this one. This is a better, more stable resonance structure than this. But there are 2 resonance structures, but they're not equivalent, okay? Here, let's talk about this guy. So I had to move the electrons to make nitrogen happy. So I could have put this double bond here or here. Both choices are the same. So the double bond could be here, that's 1 structure. The double bond could be here, that's 2. So if I said how many resonance structures does NO2 minus have, your answer would be 2, okay? And then are they equivalent? Yes, because it's a double bond here or a double bond here. It's just like a mirror image of each other. All right, let's do the next ones. So here, I expanded the phosphorus by making a double bond. If they were all single bonds, does the phosphorus have a complete octet? Yes, he has 8. So that's a legit structure. I expanded him to make him a better structure. So if I asked you how many resonance structures does H3PO4 have, your answer would be 2. Are they equivalent? Nope. 2 resonance structures. This one is better than all single bonds, okay? Because of formal charge stuff. And we always pick the best structure as our final answer. Here, let's see. So if I have all single bonds, does the sulfur have 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So all single bonds count. I made a double bond to make it the best structure, but the double bond could be here, here, or here. So I had how many choices? 3. So I have 3 choices with the double bond, and then if they all have single bonds. So that means there's 4 resonance structures. SO3 2- has 4 resonance structures. The single bond, all single bonds, and then 1 double bond, I had 3 choices. Now, are they equivalent? No. The single bond structure is less stable than having one of the double bonds. So the 3 resonance structures with the double bond, it being here, here, or here, those 3 are more stable, better resonance structures than all single bonds. So there's 4. These 3 are equivalent and higher than this one. So you can almost do it like this. These 3 equivalent and higher than this guy. Here, how many resonance structures? None. Because this is the picture Everybody's happy, there's no double bonds, there's nothing, just one resonance structure, and that is it. All right, so that's resonance structures. I know it's a little tricky, but just think about how many different pictures could you have drawn that legit would have had at least a complete octet for everybody, and then count them up, okay? So now we're going to just refresh about the concept of exceptions. Who can have less, who can have more, just make sure we put that on one side so everybody's good. And then we're gonna move on to a new topic. Now that we know how to draw resonance structures, Lewis structures, what do we know now about that?